Now, the second part of this question is a little bit more complicated. So let's scroll down here and have a look. Okay, so let's read it. It says, a car manufacturer is developing a new model, Model Y. The production goals are that the probability of Model Y requiring an oil change at any given 6-month service, so this is oil change, will be this, and the probability that the Model Y requires an air filter change will be this. The probability that Model Y requiring both will be this, where m and n are real positive integers. Determine m. In terms of n, if the probability of Model Y requiring an air filter change without an oil change at any given month, 6-month service is 0.05. Okay, a lot going on there. Let's just kind of take stock for a moment and really appreciate the fact that they've given me a piece of information here. They've told me that the probability of having a car without an oil change. So without an oil change would be O dash. So requiring an air filter change without an oil change. So that would be air filter intersection of no oil change. It doesn't really matter which way you put that, but I just want to do it in the order that the question gives us. So air filter without an oil change. They've told us that this is equal to 0.05. So you need to take note of that. Now, they've given us all this crazy stuff here, but it's really no different to what we've seen before. We're again going to create a Karnoff map to answer this. So the real trick to this question, I believe, is not freaking out and just realizing that it's pretty much the same as the top one. We're just going to go A, not A. We're going to go O, not O. And we've been told that Model Y requiring an oil change will be m over m plus n. So that means over here, m over m plus n. And the probability that it requires an air filter change will be this. So air filter will be n on m plus n. What else are we told? We're told that it requiring both will be this. So 1 on m plus n. And I think that is all that we've been told here. So let me just kind of partition this off so you can clearly see it. Now, what we're trying to find is m in terms of n, and we've been told this information here. Now, A intersection of O dash, that's this one right here. So it's pretty much the same as the top one. Yeah, A intersection of O dash, A intersection of O dash. We're trying to find this one. How are we going to find this? Well, we know that it's equal to 0.05. And we also know that the way that you would find this if you didn't know what it was, is you would say, well, take this, n on m plus n, and subtract it from this, 1 over m plus n. Now, we're in a great situation here because our denominators are the same. So this will be 0.05 is equal to n minus 1 over m plus n. Because our denominators are the same, we can just minus the numerators. Now, this is, I think, probably the trickiest part of this question, and that is recognizing, as it says here, we want our m and n to be in terms of real integers, positive integers. That means we want to get rid of this 0.05. What we want to write it as is 1 on 20, which is the same thing. So that's what you just have to realize there in order to continue answering this question. So now we can do this. And now I'm going to go a bit further down the page here. I would multiply across. So I would take this, multiply that there, take that, multiply that there. I'm going to get m plus n is equal to 20 n minus 1. M plus n is equal to 20n minus 20. Now I'm trying to solve this for what? Determine m in terms of n. So I'm trying to solve it for m. So that means I'm going to get m is equal to 20n minus 20. I'll minus n because I want to get rid of this n here. These n's look kind of funny. They look like h's. N. So that means I'm going to be left with m is equal to 20n minus n is 19n minus 20. And that, everyone, is our answer. Hopefully you found this helpful. A really neat little question. And one that, it's not too tricky as long as you don't freak out. Do not freak out when you see questions. You can do this. Believe in yourself. You've got this. See you later.